Hello everyone. Today we will learn glaciers formation and classification. Learning objectives. After studying this module, you will be able to understand the glaciers as an open system of matter and energy, comprehend definitions and formation of glaciers, and recognize and explain the various types of glaciers. In the studies of physical geography, several geographers worked on the glaciers, how they act a geomorphic agent in shaping the mountain valleys. The role of glaciers in shaping the surface features has minor importance. It is to be noted the percentage of water available on land surface accounts only 2%, which exist in the form of ice or glacials. As the temperature decreases below 0 degrees Celsius, the moisture in the atmosphere condenses and freezes in the form of snow and comprise light, fluffy and easily blown away. The regions in the high latitudes and high altitude obtain snow in the winter that gets melted in the subsequent summer. The entire snow does not melt, but some of it accumulates and results in perpetual snow cover. These processes occur in many parts of the world such as Greenland, Antarctica, Arctic regions, as well as in the top areas of high mountains. The snow line is a level above which the cover of snow is everlasting, and this line varies from the sea level at the poles to 4,800 meters at the equator. Let us begin with glaciers and open system. In cryosphere, glacier is an important portion where the two low temperatures that water available primarily in the solid or frozen state. Apart from the glaciers, the other composition of cryosphere includes perennially frozen ground, snow and river ice, etc. On the planet Earth, the most glacial ice exists in the polar regions above the Antarctic and Arctic circles. In such regions, sea ice forms a vast sheet over the polar seas, but fluctuations occur seasonally. Usually, it is very thin, 3 meters or less. Size is not much large as the ice comprises in large ice sheets, but it has a significant impact on global climate since its surface is highly reflective. In Antarctica, the average thickness of ice cover is 2,500 meters, while it is 1,500 meters in Greenland. It is estimated that approximately 10% of land of the Earth's surface is covered by ice, but 20% of the land surface had been covered by ice during the Pleistocene epoch. In the Pleistocene epoch, glaciers imprinted their marks more than several millions of square kilometers on the surface of the earth. The landscape where mechanism of glacials takes place and creation of glacier land features, both erosional and depositional, occur is termed as glacial topography. The glacial topography has much importance in East Central North America and Northwest Europe. A glacier is an open system like a river or stream. The entering of water into the system primarily in the upper portion of a glacier, in which the accumulation of snow and is changed into ice. The components of a glacier include the zone of accumulation at upper segment and zone of ablation or zone of wastage at lower part, and a fin line separates these two regions. The ablation is the coalesced loss of ice through sublimation and melting processes. In the system of glacial accumulation occurs at all places on a tributary and a main glacier. Simultaneously, the loss of snow through melting and ablation processes takes place in the entire glacier system, although highest loss of ice inescapably occurs at the lower portion where the high temperatures present. When glacier terminates into water body, there are the special ice wastages goes on. At the termination points, glaciers break off and float away is called calving, and icebergs are formed in the polar regions. The mass of ice will move or retreat in accordance with balance between accumulation and the ablation of the ice. Generally, the annual accumulation of ice is much higher than annual ablation at the head of the system, but they are equal at the fin line. In order to balance the ice's volume on both sides of fin line, the ice masses move constantly across the line. Definitions of glaciers. Several scholars have defined glaciers differently. Generally, a glacier can be defined as a relentless dense ice body which is regularly in motion under own weight of it. According to the Skinner and Porter, a glacier is a permanent body of ice consisting largely of recrystallized snow which shows evidence of downslope or outward movement due to the pull of gravity. Williams defined glacier as a large mass of ice having its genesis on land and represents a multi-year surplus of snowfall over snowmelt. According to Varesta, a glacier is a mass of snow and ice that moves slowly over the land away from its place of accumulation. Thornbury defined a glacier as a mass of ice and fin formed by recrystallization of snow and melted water which lies entirely or largely on land and gives evidence of either present or former movement. Formation of glaciers. The formation of glaciers occurs in the regions where snow accumulation is higher than melting. In other words, the accumulated snow in a region gradually converts into ice. This process usually occurs in many regions such as mountains, plateaus, or in heads of the valleys which are above the snow line. There are certain processes that involve and responsible for understanding the formation of glaciers. In the snowfield area above snow line, glaciers form by the process of transforming the snow into ice. This transformation process continues in a regular sequence such as sublimation, recrystallization and compaction under weight. This process of formation of ice associated to several atmospheric conditions like pressure and temperature. For instance, a low annual average temperature, abundant and continuous fall of snow, altitude of mountains, plateaus and latitude of locality, and presence of appropriate landscape and relief features. The mechanisms involved in ice formation cause materials densities to rise. As snow accumulates due to drifting and concentrate precipitation, lower levels become more compacted. Then the melting point somewhat drops as the pressure rises. Ice granules are created when the melted water percolates through the snow masses, cracks and refreezes or regulates around the snow crystals. This process happens much faster in temperate areas where temperature hover around 0 degrees Celsius and temperatures stay above freezing for extended periods of time than in the colder conditions of Arctic and Antarctic.